Yo, 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 what's up? Good morning. And welcome to hopefully the last day in a while of reflections. We have a pretty good result. Good performance, good visual result. It's not perfect, and that's why I'm probably going to revisit it down the lines. But we're not going to put more time into it right now, or after today, that is, because this is what I've planned for today. We're going to get rid of some of the easy artifacts, so when we try to reflect something that is off screen, we can see it here. You get this jagged cutoff pretty much. We're gonna fix this by fading the fading out this edge here, so the closer we are to screen end, the less alpha we're gonna have, basically. Or yeah, so we're gonna get a fade out here. Secondly, we have this little issue with the sampler. I don't think it's visible. We have some flickering actually. But you see this brown color, it's pretty much bleed, because although we have defined our sampler in the shader as a point clamp sampler, it doesn't seem to be doing its job completely. So I'm wondering if I'm relying on the wrong macro, and maybe we just should sample the texture in a little bit of a different way. So we're going to try and see if we can get to the bottom of those two issues, and after that we're going to call it quits for now. So we're going to take what we have when it comes to reflection, we're going to put it in our own file, restructure it like a pure function. So in the future, in every shader that needs reflection, screen space reflection, we can just include that little shader file and call a function with a set of parameters, and we're done. So that's the idea. You never know, but hopefully this won't take too long, and we will have plenty of time to apply the or first of all create some simple angle-based shading on the water, like view and light and such, and then apply the reflection just to see how it looks and how it runs. So yeah, that's pretty much the plan today. Sounds good. Yo, what's up, Luke? Or a slime in a hoodie. Hope you're having a wonderful day so far. And you too, Derek, by the way. So yeah, that's pretty much it. So let's start by improve it, or minimize this artifact. Look at the sampler, and then put it into its own file. I find it a little bit, yeah, we have this issue still. Let's see here, 1515, 0.03, depth thickness 1. I just have to double check one thing here. Yeah, it's mostly good enough, honestly. Diligence. I learned yesterday that Batman in Swedish is Not really. I think we spell him like this, but let's see here. So this is purely in Swedish, Läderlappen. And yeah, believe me when I say we here in Sweden laugh at it as well. It's like one of the funniest superhero names. I know. I just need to check if we translate it the other way. The correct translation the other way. What is it? Leather patch, I think. Yeah, it's funny as hell, man. Okay. Luke, if the reflection is causing artifacts from being outside of the viewport, would just stretching the last pixel help? In this case, it would help. You're entirely correct about that. But, let's see here. Unfortunately, you also have a case like this. So if you would stretch this one, you would have this gray sphere going all the way down here. So unfortunately, we can't really rely on that, unfortunately. So we're gonna do what a lot of other developers do, and we're just gonna fade. So the closer the screen space ray is to the edge of the screen, we're gonna remove some alpha here. So yeah, I might have said it before you entered the chat, so let me just reiterate it real quick. So what we're gonna do today is we're gonna fix this sample issue we can see here, these brown bleeding. We're gonna fix or clean up this so it's not as apparent, and then we're gonna move this reflection implementation to its own function so we can call it from multiple different shaders, and then we're gonna apply it to the water and hopefully get some wonderful result. But yeah, first of all, I'm gonna start by updating the issue at hand because we have this artifact as well. So I'm just gonna state the artifacts we have, the artifacts we want to fix, and the artifacts we won't be able to, or that we will put on hold until a later point. Basic. So one artifact I want to put on hold until later is when we look at the very steep angle, we have this issue. We can probably fix it by just 0.5 heightening this or make it thicker, but we're gonna wait with it because I don't really have the time to work with that now. Banding when reflecting at steep angle. That's one issue. The other issue I want to fix is this one. Bleeding non-reflects from objects reflecting in front of correct reflection. Do we have any more reflection artifacts that I'm gonna put on hold until later. Oh yeah, this one. Incorrect reflections at reflections at edge of screen. Going through reflection surface. Yeah, hopefully I will know what that means a couple of months from now. Okay, now over to the artifacts I want to fix. Texture, sampling, bleeding. And then we have cut off reflections at edge of screen. Anything else? We have a maybe that is, although it seems to be mostly fixed now, we never reflect the backside of the objects because of, we have a check, so we just throw away backside reflections pretty much. It's pretty much, we check how the ray enters the intersection. If we're coming on from behind, we don't reflect it. If we're coming in from the front, we do reflect it. So right now what we see is on the backside of this bed, we just see pure black here because we don't reflect it. You have the same with the stool, or the best example would probably be the pillow here, or the chin here. What we could do instead, which is probably gonna give us a better result when we distort this reflection, is that we count those intersections and we reflect those intersections, but we add a colorization to it. So if we would reflect the side of this mattress that is looking towards the camera underneath the bed with this exact shading, it would look weird. What we could do instead is reflect this one, but we'd bring the alpha down to 0.5 or something, making the reflective surface, colorize it more, and we could also take whatever color we read here and just multiply it with 0.5. So white becomes gray, beige here becomes a darker beige, blue would be dark blue, and so on. It's a little bit of a hack which really helps sell, or would remove some of these gaps here. Yo, good morning Harukanan. Hope you're having a wonderful, what the fuck is it, Wednesday so far. So that is something I want to fix as well, but this is not really an artifact right now because we have made a decision to throw away those reflections. So it's an improvement, I would say. So here I want to add reflect wrong sides of objects with additional, or with blending, instead of throwing them away. Base more properties on camera angle, base more properties on distance from camera, just to optimize it a bit. do we have something else? Oops. Yo, what's up, Coolers K? Hell yeah, it is. That is 100% the goal today. We're gonna finally apply these reflections to the water and continue with the water. Yeah, I'm probably gonna come up with a few other things we can put here eventually, but for now, this is pretty good. Already done. So what we're gonna do today is we're gonna fix this one. We're gonna fix this one. Then we're gonna do this one. And then we're gonna do this one. Right. So we're gonna start with this one. Hopefully it won't be too hard. I think it has to do with the fact, if we take a look here, we zoom in and we can see, yeah, we can see the bleeding here. So it's pretty much the artifacts you get when you use bilinear filtering on the texture instead of point filtering. To my knowledge, we have this sampler defined as this, so point and clamp, so we shouldn't be seeing this. So what I'm wondering is if it's because of the fact that we do this instead of another sample type. And what I'm talking about is that we're going to use, I think it's a method on this class, I think. So it's what we want to use instead is something like return scene texture dot sample. We're gonna have to do a Google on that one. Yo, good morning, Geralt, and good morning, Ray. Still working on shaders. When will you work more on the game itself? We're gonna get there. We're gonna get there. I promise you. But yes, for the next couple of weeks, it's probably gonna be some shaders, some more shaders, and then we're gonna get back to. I haven't really decided yet if. I have a few tasks lined up. Some are more gameplay related than others, but we'll see. Unity HLSL sample text 2D. Yes, there we go. I think we need to do can't I see a result from this one? Fuck, so we should be using this one. No, this one I mean. Yeah, we should be using this one. So text type, yeah, okay. So I was pretty spot on. Scene texture, sample, and then we do the sampler, which is scene texture point clamp sampler, and then we do current point SS. And then I hope that this is the answer. But from what I'm seeing here, that's not the case. I find this to be, so pretty much what we get is, am I naming this one wrong? We pretty much get the same result as if we would have done Can't I rename it? What the fuck? Why doesn't this one work anymore? Output. Okay, it seems to work. We pretty much get the same result as if we would have done this, I think. Okay, how do they want us to write it then? If we do yeah, we pretty much get this result at all times, right? But still some small flickering, that's true. Very weird. Because we could do, let's see here. If we just return this, the first thing we do, UV, yeah, here we can see these points right here. And we can do it like this. Let's take the pillow. I think that should do it. So what we're doing now is we're reading the texture. We're doing point filtering, so we get these very pixelated edges. And if we do oops, bilinear, do we see any difference here? No, we don't. Okay, this problem isn't going to be as straightforward as I would have hoped. This is going to be annoying. If we do Unity HLSL point sample texture, Unity 6, yeah, let's rely on that one. Okay, why would we like to rely on these instead of this is my question. Cooler, there is no game, only water in endless fields of grass. Yeah, it's a con of mine. I say that I'm gonna develop a game, get people pumped, but then I only develop grass and water all the time. Alright, shaders. Vaporware indeed. Yo, what's up, Calvino? Creature collecting game set in a world with only water. Everything built on top of rafts. Sounds pretty intriguing. I'm not gonna lie. Okay, Unity provides several shader macros to help with declaring and sampling texture using this separate samplers approach. The above would compile on all platforms supported by Unity, but would fall back to using 3 samplers on older platform like DX. Okay, nice. How this way a shader could be rewritten to reuse samples from other textures while sampling more than one texture. Ooh. But I wonder what these macros does that this one doesn't. Interesting. Okay, so instead of relying on this sample, could we do return Unity sample text to the sampler, scene texture point clamp sampler current point SS. Although I'm starting to think, or undeclared identifier, where do we have this one defined then? Yeah, Cooler SK, I don't think you're that far from the true. I think we're gonna put CG Inc. HLSL support. CG includers. Nah, fuck that. Okay. So what can we do? What can we do to get rid of this very annoying bleeding? Flickering, actually. Oh, I forgot one thing we're also gonna add to that we need to do today as well. Can't believe I forgot it. Fix artifacts. Add outlines to reflections. There we go. So why do we have this issue? Forward renderer create scene texture after rendering skybox. Yeah, that might be it. Whoa. Yeah. That should mean this could probably be it, because we're pretty much using the previous scene texture, the previous scene color texture for this frame, when we should be using this frame's scene texture. I think the reason for this one is honestly because I wanted to get the skybox for free. Let's see here. So I guess I want to try and do, if we get to this point, let's just try and do, first of all, return scene texture sample. I'm really gonna have to learn to rely on this one instead of my macros. I think this, like, it's the new way to do things. Current point SS, do we have that now? Current point. Oops, return. I'm fine with one. Yes, okay, I get it. We don't want to do this here. The smallest depth difference, we're gonna have a limit here. If this one is not, welcome back, Harukanan. Okay, so this is what we have. I think the flickering, it's not because of how we read this or we sample the texture. I think that's fine. It's how we create the scene texture. So we render the reflective surface, and then we create the scene texture for this frame, which means that we do it the other way around. That's bad. So I think we have some flickering because we're trying to, like it's a little bit uncertain what happens with render textures or textures, temporary render textures between frames. It's a lot of cleanup, unsecure memory and whatnot. So when we create the scene texture, we want to use it in the same frame. We don't want to rely on the previous frame. Which means that we could hopefully fix this. I'm gonna try that soon by changing the order here. We want to do it after rendering opaques, but that also means that we don't get the skybox for free, which I want to test now. So basically it's I don't think we want to get the skybox for quote-unquote free, because if we have a ray that reflects straight upwards, it's gonna hit, and we don't have any object in the way, it's gonna hit the skybox, right? We want it to reflect the sky. If we only rely on the scene texture, we don't have the information of the sky for that pixel. So in the future, this is gonna be a joy for people that complain all the time that I don't implement the actual game, only shaders, but we're also gonna do a custom skybox later on. So in the future, the custom skybox is probably gonna be a shader function as well, which means that when we reflect the skybox, we can just call that method and calculate it for points that are not even visible on the screen. So the skybox is always going to reflect in a good way. Currently we rely on Unity skybox. It's being rendered after everything. I don't know exactly how it's being calculated. We can check. We can probably check it out, see if we can use it for this one. So it's a lot of things going on here. First of all, what I want to do is I want to identify rays that are, we're going to call it dead rays. So it's rays that just shoots out for infinity. If they do, we're just going to take the current point of the ray and reflect that for now. And I just want to do that because I want to make sure that we get the skybox for free here by doing this. And then we're hopefully going to move this one to after opaques. We're going to research if we can calculate some skybox values in our shader for reflections for dead rays. And yeah, hopefully by changing this one we will fix the artifact, but yeah, I don't know. So we need to identify dead rays, and I'm wondering here, so we do the first pass, we move quickly along the ray. We have something called smallest depth difference here. If this one is bigger than some value, then we want to return, or we want to mark the ray as a dead ray. So we're probably going to, oh fuck, do we have true here? That's not good as well. Actually it is. Some leftover code from when we wanted to fix something yesterday. So it's basically going to be if we have a dead ray, return whatever point we are at. Otherwise, do the second pass. So we're gonna do depth, thickness. What do we have? It's D, so yeah, it's depth, thickness. We're gonna do infinite ray depth threshold. Let's go with 2. So let's just start by doing if smallest depth difference is less than or bigger than infinite ray depth threshold, return 1. What did I forget? Oh yeah, of course. And yes. Okay, so a little bit uncertain about this result, but what do we have? Infinite ray depth threshold 2. Okay, that looks pretty good. Still, I hate this. So, yeah, when we start reflecting the sky, we might want to get rid of this one, actually. That is true. 0.1. We probably want to... Yeah, we're gonna do this. If it's smaller than this one, then we do this. Otherwise we return black. Okay, that's good. And I wonder, we probably want to we probably want to do this. If a ray has its endpoint within the screen, then we want to return whatever color we have on that pixel. If the ray goes, if the ray goes outside of the screen space, we want to return the skybox color, right? So if we have a ray that goes far into the distance and end up like here, we want to return this color. Same if we have a ray that goes here, but if it goes up here, then we just want to return the skybox. So we have our array defined. We have end SS. And we have a check, is point within screen bounds break. Instead, I think we want to do, so we can start by doing return is point within screen bounds array dot end SS. If it's true, return scene texture sample array.end SS. Otherwise, we want to return the skybox, but for now we're gonna set 0 here. What do we have then? That fixes the sky. But we also get this problem. So we need to check I think that's true. We don't. Do we get the ground eventually? No, we don't. I would love to see part of the ground here. And when it comes to this problem, yeah, we have an infinite ray here. We don't have any information here. We return that one. Okay, so we need to differentiate between being behind something as well. We could probably do I worry that 1, 2, 3, 4, 5, 1, 1, 10, 100. Okay. Okay, we can't simply rely on reading from the endpoint screen space. We could actually compare it. I think this one is probably pretty easy to solve, this one as well. But the fact still remains that we want to reflect this. But actually, maybe, let's see here, maybe, min max, $60. If we do let's see here. Yeah, doing this, I think we can do it like this. Let's see here. I'm gonna do. Let's do. Let's add a sphere. Let's move it way back, and let's go. Yeah, okay, so we're actually gonna reflect this if we would have gone low enough. But what we need to do here is when we do infinite race, we want to double check one more thing. We want to double check if the depth of this one is bigger, or like we want to make sure that we are at the correct side of the object. So if we take a look at this one, this reflection right here, the ray, the dead ray or infinite ray, is way behind this object. So then we shouldn't return it. But if we're in front of it, we want to return it. So we need to do if is within screen bounds, and let's do it like this. Bool within screen, or and then we also want to check get ray depth v as ray 1. If this one is less than sample scene depth. And then we also want to do linear eye depth. Sample scene depth, ray dot end ss, and always forget C buffer params. Like this, I think. Is ray and in front of scene, ray and is ray and I would want to do it that way around. Is ray within screen bounds and is ray in front of scene. If so, then we want to return this one, otherwise 0. Oh yeah. Do we want it the other way around? Okay, yeah, the problem is that this one is not far enough away, so we can do ray max length 100, and there we go. And yes, the problem is pretty apparent. We still have this issue, which will be not solved by but minimized if we hit the if we don't hit anything. So that's another check we want to do. If basically if this ray isn't in front of anything or behind anything, then we want to return the skybox. So let's see here. I just want to check. Do we have a skybox node in shader graph? No. We don't have a texture here. That's, yeah, that's what worries me. So in our case, if we take a look at lighting environment skybox prettier, we would pretty much need to duplicate whatever calculations is going on here. We should be able to do let's try this one then, I guess. Damn, are you kidding me? So let's see here. We could so as I mentioned, in the future I probably want to have my own procedural skybox. We can do it as a there's multiple approaches we can do here, but I think I'm gonna take the lazy one today, and the one that yields the worst results. So I think we're pretty much just gonna return a solid color that matches up with the procedural skybox. Other solutions would be to add a custom render pass that just takes, or that pretty much renders a low resolution cube map of the current procedural skybox, which I'm tempted to do. Because that could be one of the that could be the solution for low-end hardware for reflecting the skybox eventually. So let's just ponder the like if we had a skybox that we wrote, so it's a fully procedural and it's a shader function pretty much, which we can call from multiple different shaders. So then we have an object, a sphere or whatnot, around the world where we render the inside of it, and we use this procedural skybox shader. So for this point we would render this point according to our procedural skybox shader. But this point, when we reflect down here and we render the same point but in the reflection, we would do the calculations again, which means that for certain pixels you would do the calculations twice or more, maybe. Instead, there's probably a trade-off, but instead we could render this one to a cube map and then we read from the cube map here. I don't know which one would, depending on how complicated our custom sky shader box is, the texture way could be a little bit cheaper. But yeah, for now I think we're probably just gonna go with a color, which means that we unfortunately won't be able to get this nice gradient, and also where the hell do we have the sun? I don't even know, it's not visible, but yeah. So we could do lighting, or let's go to Skybox Prettier. Do we have ground sky tint? Yeah, we don't get the correct color of this. Fuck it, I just want to do... Let's just pick whatever value we have here. And also if we simply do it like this, you won't, like the reflections won't be affected by things that affect the skybox. So the angle of the sun, and a lot of other stuff. But for now, I think this will be fine. Infinite array. So can we do okay, yeah, let's just recalculate this one then. Let's just put it at 0 as default and change it here. And then we do, let's compare how it looks. If we have this result and we do yeah, we want to put this one here, which will ish get rid of this one. We're also going to lower the alpha for distance. So let's see here. Okay. Luke, I'm heading out. I hope we get to see the rewards of this effort next live stream. Alright, thank you for stopping by. Hopefully we'll see it at the end of this live stream, but yeah. That's the goal, at least. So let's see here. I wonder if we only want to check this one. Good luck. Thank you. Appreciate it. Whoa, 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 whoa. Interesting. Did I screw something up? Oh yeah. Okay, is ray end within screen bounds? And let's check. Oh. Yes. I want to avoid this one right now, so if we do... let's see, I want to return... linear depth, current point SS, no, ray dot end SS. Oh yeah, of course. Inverse lerp. Okay, let's return. So yeah, for this one, this bothers, maybe not. For this one right here, the ray or the depth at the scene is bigger than this one, so Fuck, we could probably do... like this. Get ray depth. Here we want to do... We don't want to add an extra interpolation when we don't have to. And then we can do return is ray infinite. Infinite. Not exactly the result I was maybe. 10. In fact, didn't we just do... Oh, yeah. But it's something like this we want to do. Is ray infinite. We should be getting true here. We're looking in negative z directions. We need to do add a subtract before here. If this one is bigger than projection params, yeah, I think we're limiting this one. Maybe we don't want to do... Maybe we don't want to limit it. But then again... we can probably do it like this. So we do... Or do we limit it? We do project params y. We need to take this one into account as well. But what I'm worried about right now is... Don't we have it somewhere? View direction, reflection. Yes, okay, we never get infinite rays because we have limited here. I thought. I reckon a much better way to do it is... A much better way to do it is probably to just do no, that won't work. We send in length vs. Yeah, here we have it. What the fuck? Mean ray max distance. But then again, yeah, it's this one we want to change. Is ray in front of scene? When we sample this one, we also want to sample, let's see here, depth is equal to this one. So this is in depth is represented by a value between 1 and 0 here, 1 being close to the screen, 0 being far away. It's non-linear, but if it's 0, we know that we don't have any object there. So we can check that this is true, but also depth is not equal to 1, I reckon. So if depth is not equal to 0, so if depth is 0, we return false. If it's not 0, then we check what the depth is there and compare it to the ray depth. If the ray is in front of the object, we just return that one. What would this give? Fucking hate that we're not getting this one at this point. Why is... oh, yeah. Okay, that's probably the best result we're gonna get with the information we have currently. Okay, with that, a little bit of an artifact there, nothing we can do. We also have the head here, but that's okay. Okay, I think that's good. But I also wanna do... Okay, let me commit this real quick. Yes. So I would say improvement. Do we have, yeah. So what do we have right now? We have, let's do, okay. And I also want to do copy material properties. Okay. Add skybox color to reflections. Texture sampling bleeding. Do we have it? Yeah, we do. Here. So I want to see if forward render create scene texture after rendering. Ah, fuck me. After rendering skybox before rendering transparent, we render. My assumption was wrong. We actually render skybox before transparency. Yes, of course we do. But if we do after rendering opaques, yeah, we still have it. Why? Hmm. It's definitely not as apparent right now. Hmm. Hmm. Have we changed something that removed this issue? Could it actually be fuck yeah, okay. Okay, I'll take it. But why? Hmm. It's right within screen bounds. Yeah, it could probably be. Okay. It's probably rays that don't hit anything. In the first pass. So smallest depth difference is 1,000, which means no, that can be true. Wait, what we get here is nah, it probably rays. It's definitely rays that for which this is true. But this one gives us a point behind the reflective plane, I think. Let's see here. Inverse lerp. So I just want to try and do, if t is less than 0.0, the flickering annoys me as well. But it seems to me that this one is the one that gets rid of it, right? How does that make sense? I don't know. Interesting to say the least. Very interesting. Okay. I'm just gonna take that one as a win. Okay. It's not texture sampling bleeding though. Yeah, if I find myself having the time someday, I might dive into it more, but incorrect reflections at the edge of screen going through reflection surface. Actually, we're gonna do this. What do we have? Can we do fixed by, or is it just beautiful? But okay, good. I want to check, maybe this one is also fixed. No, not this one, but this one. I want to double check that. Yo, what's up, Mercenary Mage? Hope you had a wonderful stream, man, and thank you for the raid. Appreciate it. I think it got fixed by this one as well. What the hell? That's good. If we compare... Or did we fix it previously? Huh. We had a problem with the ground showing through here, but we don't anymore. Okay, that's perfect. But could that be because you have changed? Let's do 0.2 4. No. Is it because... No. Okay, unfortunately we're gonna have to put this one up to fixed by as well. Let's just add a little bit of a question mark. I'm gonna question in a couple of months. Okay. Cut off reflections at the edge of screen. Yes. So this one is probably the last one of the artifacts I want to fix today. So this one, what do we have on the clock? Okay, we can probably still do it. This one I still want to fix. This one I want to fix. Then this one, and then water. Okay, let's see. Decrease alpha reflection based on distance to camera. We're gonna do artifact reduction variables. Reflection decrease fuck, what do I want to call it? It's basically we're going to decrease the reflections close to screen space limits. Reflection decrease. I think let's just do it like this. Reflection 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 screen space full reflection screen space limit. That doesn't make much sense. Reflection drop of distance. Reflection drop of distance screen space. What the fuck? Okay, we're gonna do some calculations with this one. What do we have it? So basically we need to think about a couple of things here. But what I'm aiming to do is, if we have the screen like this, then we're gonna define an area like this, where this distance is our parameter. And we want to do this in like normalized screen space. So basically we have 0, 0, 0, 1, 1, 0. So if we use the same C for both, so what I mean by this is we have the screen within this area, the reflections will be unblended. Within this area they will be blended. They will be more blended here, less blended here, basically. So this is how the blend will go. But if we use C both here and here, since we're in normalized coordinates, that means like, so if C is 0.2, since we have a most likely an aspect ratio that is not 1:1, that means that the fade out will start, or yeah, it does, right, will start earlier here. Yes, like 0.2 in the x-axis is more pixels than 0.2 in the x-axis. 0.2 in the x-axis is more pixels than 0.2 in the y-axis. So let's do float 2. What did I call it? Depth threshold? No. Something threshold. I thought, or limit. We called it reflection drop of distance screen space. Yo, what's up, Tard? This is so cool. Yeah, I think so as well. Not a perfect name, but whatever. I think we can calculate it here. So we're gonna do reflection drop of distance screen space is equal to float 2, and here we need to figure out the ratio we have. I think we can use XY, but we also have screen params, I think, don't we? Unity, HLSL, constants or variable built-in shader variables. So many float variables, hell yeah. What engine are you using? I'm using Unity, but currently we're writing shaders, so it's HLSL. Screen params. X is the width of the camera's target texture in pixels, Y is the height of the camera's target texture in pixels. Z is 1 plus okay, we can probably do we're gonna go with X as the deciding factor. So X here is just gonna be reflection drop of distance screen space, and Y then is gonna be screen params dot Y divided by screen params dot X times this one. Am I doing this the correct way? So if we have 0.2, 0.2, 256, 512, 0.2 times 4, 288, but if we do 0.9, no, we're doing this the wrong way, right? Yeah. So again, it's 256, 240 times 0.2 times, yes, there we go. What's up, Roy Patson? Explain Unity and programming. I don't really have the time for that right now. Tara, sick. I always wanted to get into Unity, but breaking Godot is going to be so much more fun. Yeah, don't oppose that. I'm really fond of Unity. I was a little bit shaky there for a couple of months when they, I don't know what the fuck they did, but or what I should call whatever they did. But yeah. They still got that shit plan installed, question mark. No, I think they reverted it, the install fee stuff. And as to what we're trying to do here right now is we're trying to minimize we're trying to minimize this artifact here. So when we do screen space reflections and we can't reflect any something because it's outside the screen, we want to reduce the artifacts we get here. And we want to do it by reducing the reflection color. So blend with, we probably want to blend with this color more than we do. Just to reduce this sudden cutoff. And I want to make sure that since we have a wider screen than we have, it's wider than it's the width is bigger than the height. So I just want to make sure that we fade out this in the same number in the same. I just want to make sure that the fade out distance is as long in the X direction as it is in the Y direction. And that's why we do this. So when we fade out later on, we're gonna do reflection drop-off distance square space. Yes, we're gonna take this one. So we're gonna do some stuff here, and the stuff we're gonna do is we're gonna calculate float to distance to, what did we call this one? Reflection drop-off distance screen space. Distance to screen space limits is equal to current point SS minus reflection drop of distance screen space let's see here. So if we take the X direction, we have 0 here, we have 1 here. So basically if it's we want to take 1 minus screen space position, I'm going to call it UV here. So if we have 0.9 or 0.1, for 0.9 we get that's not really what we would do. Oh, we could do it like this. I wonder. Ooh, maybe a better way to do this would be, we have our middle point, but that will screw it up, the ratio, because we could do distance, but we could solve that by multiplying the Y distance. Tara sleeping to this eventually, hope you know. I appreciate it, I appreciate it. Why don't you just add a material? I don't know exactly what you mean by that. But let's see here. I wonder if we can do distance and we multiply how would that be? So we do I want to try that. Let's see. Do we have test A? Yes, we do. We don't use it. So let's try and do let's do return distance between float 2 0.5 0.5 and float 2 current point ss dot x, and here we do screen params x divided by screen params y times current point ss dot y. Distance. But actually I want to do this for, we can just do it like, let's take this one and put it here, maybe. Let's do current point, let's change this one to ray.start ss. Ray.start ss. Just add a formula to account for the change you want to make, like procedural generation. I get it now, this is purely shader. Yes, it is. Okay, this is good, I think. If we do plane and let's scale this one to 100. This is not what we want. Tar, I was saying add a material if you don't want it to be as reflective as you have it. As long as it's not opaque, you should be fine. Okay, so the fact is, or what we're actually doing here, is we're implementing a custom screen space reflection solution, because we want to extend it later down the line, and we also want it to work with our outlines. Okay, distance float 2 0.5 0.5 should be the middle of the screen, right? Cody, thank you for the follow, appreciate it. Does this one screw up? Okay, I screwed it up. Okay, that's beautiful. This is exactly what we want to see. So the ratio correction, but here we see it, we want this one to be circular. It's elliptic. Right now we want it to be circular. So we're just working to save time later down the line. It's pretty much the opposite. What we're doing now is wasting time. We're not wasting time, but this takes way more time than it would have done just going with one of the Unity solutions. But if we went with the Unity solutions, we wouldn't be able to get the visual fidelity I want. We wouldn't be able to reflect, or we would be able to reflect outlines, but we would have some problems with how they are being reflected. Never redo something in code if it's been done. Sometimes you have to, unfortunately. Sometimes you have to. Because it hasn't been done. It's not available to the public in the way you want it to be done, right? or it's done, if it is, it might be in a unoptimized way or inextendable way or something else. Yeah. But okay, so we want to reduce the elliptic shape of what we're seeing here, and that's why we need to do some correction. And I'm thinking of this the other way around. I think we need to make this one smaller, not bigger. So yes, I was right the first time. We need to do projection params divided by projection params dot x times this. So I think this should be it. Or what am I missing? Not projection params, but screen params. Right. And I'm missing a... We're missing this. We can remove these. Okay, that's wrong as well. Just give me 1 sec. Okay, back. Sorry about that. We have it circular, but we have a weird offset going on here. Why? And if we do it like this as well, we're gonna get... we're gonna fade out way earlier the diagonal way here. But now we... Yeah, we will. Yeah, we will. I wonder if I will screw it up for some devices here with the assumption that... Nah, we should have fixed that here. Like, what is it supposed to be? This one should be located in the middle of the screen. That's about it. Why do we get an offset here? Screen params Y. What we do here is 1440 divided by 256 times something between 0 and 1. Distance. Why is this yielding an offset in the Y direction? What a weird problem to have. Yes. I want to try. Is it the X that screws it up? Oh, yes. If we correct this one, we need to correct this one as well. Right? Yes, there we go. What I'm a little bit worried about this though, but this might be something we want. So for these points here, we're gonna get, or basically we're gonna get a drop-off that is equal to like here we have a shorter drop-off, here we have a longer drop-off. I'm not entirely sure that is something I want. I think I would rather go with a square-ish drop-off. So we could do that with I think we need to do .5, 0.1, 0.4, 0.9. Yeah, I think we want to do return max, or is it min? Let's go max first, and we'll do 0.5 minus abs, 0.5 minus ray start ss.x, abs screen params.y divided by screen params.x times abs 0.5 minus, a little bit worried about, it should be okay, ray.start ss.y. Don't we want that correction? Tar, you gotta start streaming more, bro. Appreciate it. This is the first dev stream I've been watching where I'm actually liking what I'm watching. Appreciate it, man. I try to stream every weekday around 4 hours, pretty much. when I'm seeing this square here, I'm not so sure we want to correct it. Or could it be... I'm a little bit worried about this abs, that we might need to do this, but no. Okay, so it's okay to do it on the outside. So if we compare this square pattern, we have a lot more white here. As opposed to, if we remove this one, we get this. Let's see, let's do, if this one is bigger than 0.8 maybe. That's not 0.4. So we have, it's bigger here than it is here. That's the wrong way to go about it. How do we want to correct this one for it to be... Looks like a never-ending tunnel. Yeah, it's indeed. Now we're pretty much going for this. The idea is that when the white start here, we're going to reduce the screen space reflections so they fade out. Damn, what am I missing here? And if we did this, we got the same wrong result. We get this 0.4. Ah. So we probably need to do but nah. I thought this correction would do it. Definitely. But I seem to be missing something trivial. Yeah, something is definitely wrong here, that's for sure. We want to... Do we want to go the other way around here? Tara, I think it's the X that's messed up, so we're talking about this one. We could choose to correct X or we could choose to correct Y. It doesn't really matter as long as... Like, I guess we could either increase Y or decrease X. But we need to calculate by what amount. And I was pretty sure it was 9 divided by 16. That was the amount. But... that doesn't seem to be the case for some reason. Or do we need to do... Six we don't have, but 45. Yeah, okay, let's see. So basically what we do, right now this can be any value between 0... let's go through this. Right now it can be any value between 0 and 0.5. And if we multiply it outside of the abs, we get a value of a less than 0.5. So then when we do this comparison, we screw it up a bit. Tara, you have to do it by the screen ratio. That also matters. Yes, that's exactly what we're trying to do. And what you see here is the screen ratio. I think that's the only thing that matters, actually. Yeah. One sec, getting a call. One sec. Okay, back. Sorry about that. Let's see. Tar, what do you say? The way I see it, it's 0.5 by 0.5. That problem was messing you up. The y, because the ratio isn't even, because the y is shorter than the x. Yeah, that's exactly what we're sitting with. Now you're pretty much just, like, you're repeating what we're doing. This is a ratio problem, 100%. We're trying to do a ratio correction by doing this, but we're getting the wrong result. And that's what we see here. The y is thinner because the y ratio is less than the x. The height is less than the width, right? So it's a question of how we want to do this correction. I could probably, I wonder if we, like, I would like to do this. If we have y, x here, we make it smaller. If we have x, y, we make it bigger. But we make it too big. If we do 0.5, we make it too small. Screen params. Am I using the... No, we should be using screen params. X is the width of the camera's target texture in pixel. Y is the height of the camera's target texture in pixels. Tar, you're getting the wrong result because you have it set to the wrong aspect. I'm not so sure about that. We could rely on Z and W, I guess. I'm wondering if what am I missing? Why doesn't this work? The UVs are 0 to 1, 0 to 1 in both X and Y. Y is, or X is bigger than Y. X is our reference point, so that's going to be 1 for us. That's a scale of 1. We check 0.5 minus ray start. Like, we're working with a ratio of, it's a 16:9, 1.77, so X is 1.77 times Y. Tar, I'm telling you, bro, getting this squashed isn't going to be fun when your X aspect is set that low. I'm not entirely sure I understand what you're getting at. But this is what we have. So we have our screen. Our resolution is currently set to 2560 times 1440. This is going to vary a lot between devices, so we don't want to hard code those values, right? When we work with screen UVs in the shader, we work with normalized coordinates. So X goes between 0 and 1, Y goes between 0 and 1. To figure out how far away we are from the middle currently, our middle point is 0.5, 0.5, both for X and Y. And then we calculate the difference by just doing 0.5 minus whatever X or Y we have, and the absolute value of that, and that's the distance we have. But that is in normalized coordinates, which means that a distance of 0.2 is in the X direction covers more pixels than 0.2 in the Y direction. So we want to skew we want to multiply the Y so that they are in the same space pretty much. Skimono1, thank you for the follow, appreciate it. Tar, to make an accurate X off of a repeating number is like catching infinity. Now I'm not following at all. Basically what we're calculating here is what I thought would be the ratio we would use. Initially I thought Y divided by X would be correct, but that would mean that we're making this one even smaller. We want to make it bigger. Hence this, but that makes it too big. And Y. Okay, fair, but you should at least make it big enough to cover everything. I have no idea what you mean. So, after this and this, both of these are between 0 and 0.5. What it says is the length to the edge of the screen, right? In pixel values, however, these values correspond to bigger values than these. So if we would be working in we can do this, return max of pretty much what I want to achieve is this. Let's try it. What do we have? 2560 divided by 2, 1280. 1280 minus screen params dot x times ray dot start ss dot x. Abs (720) minus screen params dot y times ray dot start. Am I thinking about this correctly? If it's bigger than 100. Yes. No. Do we want to do the comparison? Yes, this one. Yeah, we want this one. Okay, I get it. Don't we just want to do... We don't need to correct shit, right? We can just do... Oh, we might want to correct this one. So if we do bigger than 0.4, bigger than 0.4, we still get this. And then if we do, let's see here, X or Y, if we want to make... Fuck me. Mumba, thank you for the follow, appreciate it. This should be pretty trivial, but I'm overseeing something. 0.1, 0.1. The ratio doesn't seem to be what I think the ratio is. Could it be that it's not as easy as the ratio? We're doing this here. Screen pos VW is equal to 1 plus 1 divided by height. It's not, you're still not accounting for y the way you should be. Yeah, that's definitely true. If we did, we would have the correct result. Oops. But look at this. Say that we want a rim that's for x. We want that rim to be 0.2, right? So it's 512 pixels. Now we want to correct 0.2 for the y, so it becomes 512. So what we do is 16 divided by 9 times 0.2 times 1440, and there we have it. So it's 16 divided by 9, which should be, unless I'm overlooking something, 16.9 should be screen params dot x divided by screen params dot y. This is not equal to 16 divided by 9, but it's equal to 256 divided by 1440 in this case, which gives us the same value. And to put it in the exact same as the example, we have this. So if we're at 0.8 in the x direction, or if we're above 0.8 or below 0.2, this one will be true. And here we correct this one for the y, but with 0.2, 0.2. Is it just nah, shouldn't be a precedence issue. We can take just take 1.7777. One sec though. 0.2. What do we have 0.4? What is the ratio we're looking for here? Then we multiply it with this one. Do we actually want to do... I don't get it. I just want to make sure I'm not missing something very trivial. So, oh, let's just do return, return. Screen params dot x times ray start ss dot x. If it's bigger than 128, should be 128 pixels, or screen params dot y times ray start ss dot y is bigger than 128. Yeah. And then if we change 128 divided by 256, 0.05, let's do it like this. Return ray dot start ss dot x is bigger than 0.05. Or ray dot start ss dot y is bigger than, and here we want the correction, because if we just do this, we get a rectangle instead. So if we do the correction as in this case, we want this one to be smaller, so that this is where I want to do screen params dot x divided by screen params dot y. And we get a perfect square, so that works. So it's exactly how we think it should be. Like, this is the ratio we want to work with. So at some other point here, I must have been doing a very stupid mistake. So let's get to the bottom of what it is. So we can do return ray dot, we do abs 0.5 Tar, stressful, but don't give up until you get it, man. Appreciate it. Yeah, I know. We're gonna fix this. It shouldn't be that hard. So we do abs minus ray dot start ss. Actually, before we continue, I want to do if it's less than and less than. Beautiful. So we want to do, now we just want to correct it so we get the other side as well. 0.5 minus ray start x. If this is less than 0.05, yeah, so here we actually want to do less than 0.45, right? Now we have x on both sides, so for the other one we want to do or abs 0.5 minus ray start ss dot y is less than change it to, yeah, of course. Let's do return. So we have this, and we have, what did I miss? But I just have to say, seeing this makes me wonder about this one. Might be overseeing something here. Less than 0.45. So I'm pretty sure we wanted the other way around. So if it's bigger than 0.05, yeah, we want it to like this. We want to check if one sec. If the so in here we want to have 1, out here we want to have some value, but yeah. Okay, so if it's less than 0.45, we return true. But that means that we're gonna get white here as well. We need to check. And Legato, thank you for the follow, appreciate it. We need to check if this is true and this is true. And then we want this one to be 45 as well. And then we have the ratio correction here. I wonder if the problem is... Oh, one sec. We also need to do 0.5 minus. So it's true for this one here. Why the fuck is it true for that one? Or for those pixels? Robert Pattinson, shoot. What am I missing here? We know actually, yeah, we know that X is only true for this here. And we want the same for Y, so Y should be false up here. This correction, however, makes it not be so. Do you have experience with freelancing stuff? Not much, honestly. So we want to do abs here as well, but then we're back at where we started. The ratio correction we do here does not yield the correct result. But if we take a look at this one, it definitely yields the correct result, right? Here we do the opposite though. Let me do could it be I don't get it. I don't get it. The only reason I can see here is that this one screws it up, but I don't know why. Okay, one sec. Beautiful. And then we do yo, PG King. Good morning, good morning. True for all. Okay. Yes. Because this one becomes bigger. Yeah, so this one is pretty much, this one is 1.7, 2.045, so that is wrong. We don't want the correction here, or at least not this correction. But do we want this correction? Oh, it's too big. Fuck, we could probably do or interesting. Yeah, this can never be true. This can never be true. But if we do the other way around, this one will never be true. Okay, so it's this one is probably the problem when it comes to this later on. Which leads me to believe that we want to do the correction here, but we want to do it yx. Okay, so if we do it here, we have the same problem. Yeah, if we do it like this, this one will never be bigger than this one. Bruce, what is the goal? 5% from 4 sides? No, non-relative offset from 4 sides. So we're pretty much just trying to do a ratio correct threshold, which I thought would be a walk in the park, no problems at all. It's pretty straightforward, but I overlooked some minor detail, or I might just be tired. Yeah, relativity sucks. Okay, look, we can take a look at where do we have it? I think this one highlights the problem extremely well. So we return true if a pixel is at the outer 0.05 area, right? It's pretty it's straightforward for X because we don't want to transform that one at all. So if X is less than 0.05 or bigger than 0.95, we get these nice white borders. And then we do, if Y is less than 0.05, but 0.05 in the Y direction is smaller, right? So we need to correct the comparison, and we do that by just multiplying with the ratio, or 9 divided by 16. And this one works for this one. They are the same absolute value in pixels. The problem is this one. When we do the correction here, we multiply it by 0. I always forget, but 0.5625. If we multiply this one is between 0 and 1. If we multiply that with this, we're never gonna go above this one. Because this one is always less than 25. So yes, I reckon this is where we want to use is it W Z? No. So how do we transform this comparison to the absolute values? I guess we could calculate it in an easier way. We could do, if we want to do it without I wonder if we could do it like we probably want to do it like Like if we move one sec, what have I screwed up here? Why don't we get... Okay, we only get X here, never Y. So ray start Y plus... And what do we get here? We get 16 divided by 9 times 0.05. So whatever this one is plus 0.08, if yeah, this one is always more. Yeah, that's true. Yeah, now I'm just... I don't think that will... What am I trying to do here? Y is between 0 and 1. And then we offset it and we compare it to something. Minus. Let's take this one. I wonder if we can just, or what I'm trying to get at is, can we transform the offset, add it to the original Y and check that one? Okay, so we have something like this. Okay, and we can do return. We want to do the same thing but the other way around. So ray.start ss.y plus this one is less than 1.0. And then we do, let's see, here to transfer, and then to this we add and Bruce, I need it to be a lead code problem to understand what I need to do. Could probably rephrase the question we're trying to do here and make it into one. Fuck, I don't know. One, 85. Yeah, this looks to be all right. we can do it like this instead. Let's do 1, 9. Fuck yeah, I think this is it, finally. Jesus. Spent way too much time on this. We want to restructure this so we work with the abs values instead. So we can do return, hopefully this work, abs, ray start ss.y, 0.5 minus this one. If this one is plus what am I missing? Plus do we want to do minus? Let's see here. If this is 0.9, 0.9 gives us 0.4, 0.1 gives us 0.4, and we want to take this one and make it bigger, plus, but this one is, yeah, and then we want to compare with 0.5, I think. Something like that, but I think we want to go the other way around, but now I think we have the same problem again. No, we don't. So then we return. Let's see, we want a white, so we do or. Okay. Ooh. Okay, but now we need to transform these. Okay, the ones that are true, i.e. it's bigger than 0.5. Or let's see here, let's do okay, so the ones that are smaller than 0.5, we need to take the values here. I wonder if we can do return min, no, max want. Pretty much what we want is we want to take these values, the ones that are not true, and we want to calculate how close are they to being true. So that means way whiter here, darker here. We probably want fully black here. So we also want to take the biggest error. So they are between. So we take the max here, and then we do return inverse lerp zero 0.5 a. That's not what we want to do. No, we want to do 0.5 yes. Okay. But we would probably like this to be the other way around, I think. One sec. Yeah, we want this one to be white. This one to be black. I guess we could just do 1 minus, but or so I thought. Okay, we're not fully white here. Good to know. Okay, why not? Why not? What can we change from the previous one? Okay. So the maximum value we have here is 0.6, right? Is it? Yes, it is, because we add 0.1. So here we need to do 0.5 plus 0.1. And that should... And if we do... I just want to check where this one is bigger than 0.5 and smaller than 0.1. We can't do it like this. Yeah, that's true. It's very dependent on this, I reckon. We should be able to use this one, I think. I'm just a little bit scared that this edge here is a bit too instant. That's what I worry about. But if we do, yeah, so if we return this, do we actually want it? Okay, let's see what kind of fade we get with this. So let's just return this one multiplied with this one. That's definitely not gradual enough. So why not? Or I guess we can do... Oh yeah, of course. Util blend. Okay, we're getting a value that's higher than 1 here and probably lower than 0. So A, we have values here that are way above and way less. Yo, what's up, Derek? Unfortunately, once again, we haven't gotten to adding the reflections to the water. We're working on just fading them out close to the screen boundary, basically. So still artifact reduction. Basically what we're trying to achieve is as soon as we enter the black boundary here, we're gonna start fading out the reflections, and we're gonna be able to decide the thickness here as well. It's just so you don't get a instant cutoff on reflections that are close to the, or that overlaps with the screen boundary. But yeah, I got stuck on a stupid problem a little bit too long, which unfortunately means that I won't be able to add the reflections to the water today. But yeah. Okay, so we calculate, in fact, let's just return A as it is. We don't get, can we do a remap here? Or A should be, remap A 0, 0.5, 0, 1.0. Derek, it's crazy how intricate such a relatively small visual detail can be. Yeah, definitely. Definitely. But okay, let's take a look at this one. What values can we have and play around with? This one is between 0 and 0.5. Then we add, we can take this x here for instance. So this one is between 0 and 0.5. And then we add plus 0.1. So it means that this one is between 0 and 0.6. So I wonder if we want to do 0.6 here. Or rather, we don't need to do this, but instead we can do I think this is the inverse slurp we want to do, but this fading, I don't know. I guess the problem we have is when we get to this point, we have a value of let's take this one. First of all, so at here we have a x that is 1. We do 0.5 minus that one, so we have, oh, the x here is 0. So we have 0.5 minus 0 gives us 0.5. Then we add 0.1. That's what gives us this one. So we have a value of 0.6 here, which means that we get a 1. And then we take this point. Here we have a value of, I don't know. Oh, not x, I'm sorry, I mean y. What do we have here? Or rather, what I'm looking for is the one when we're closest. Okay, so the idea here is that this one is at y. Let's do x because it's easier. So the idea here is that this one has a x value of 0.4. 0.4, so this one is 0.4, this one is 0.1, 0.2, that's not what we want to do. Fuck, this worries me that we lose. Yeah, that's not good at all, that we lose the ratio as soon as we... So the ratio here is actually wrong, yes, because we need to do... We probably need to do the inverse slurp ratio adjusted as well. Unfortunately, I won't have the time to do that today. Even though we didn't get to cross off all the tasks I wanted to get done today, and eventually display the reflections on the water, I still think we made some very nice progress today. Gonna continue this tomorrow, hopefully get to the end of it. Yeah, but you never know. Have a great rest of the day. Peace.